So now we're moving on to part 2 of this Photon Fusion cooking game. Cooking in air quotes, I suppose, but cooking nonetheless. When last we left, we had a game object that we sort of customized from Photon Fusion. I just realized I haven't figured out how to make it turn. We'll get there. There might be an awkward pause here in the middle of it all. You could pick up food from one place and walk it over to the other place. Let's introduce a simple cooking mechanic. In this case, we're just going to have cooking be represented by a bar that's increasing in size. And that's going to happen primarily on the cooker here. So we have the script here called stove that we're going to go ahead and open up. And we're going to begin to edit the stove script to be able to do some cooking as well. So already this has the capability to note that it has food because it has this game object here, so it knows what food it has, and it knows if it has food. So we're going to go and add a new function here. Public override void fixed update network. And this base.fixed update network doesn't really need to be there, but if you want to leave it, that's fine. And if we have a food object, so we're going to check to see if we have a food. So if has food. So if we have a food object, we're going to go ahead and tell it to progress itself. So food object dot get component food, which we haven't made yet. We will in a second. Dot cook. And we're going to give it a number. In this case, we're going to give it 0.001f. So that's the amount that we're going to cook at this time. Now, we haven't made this food script yet, so that's what we're going to work on next is this particular script. This is not going to compile for us yet because of that. So we're going to return to Unity. We're going to let the editor sort of do its thing for a moment while it realizes that life isn't good for it. It's going to throw an error, but that's fine because we're going to just ignore it for a second. And we're going to go create a new script in our scripts folder, and we're going to name that script food with a capital F. Wonderful. And we're going to open up that food script. It never opens for me correctly the first time. Can't tell you why. That's just sort of the way it is. And no surprise to us here, we're also going to use Fusion. So using Fusion at the very top there, we're going to make this a network behavior so that its behavior can be shared across all of these. I don't think I actually need to do this particular one because I think I can get away with this. So we're going to leave start for just a moment. Update is going to go. And our food is going to be attached to that food prefab that we created. And it's going to have a couple of properties. So let's start with the properties for this class. The first one is going to be the visualization for how cooked this particular object is. So public game object cook bar. Beneath there, we are going to have a string for this name. So public string food name. And that's going to help us sort of tell what food this is when we're delivering it to customers. And then we're going to make a networked object. So networked. And we're going to come back and, oh wow, I misspelled that one real good, didn't I? Networked. We're going to come back and edit this, but for now we're going to make a private float cook progress. And it's going to have a getter and a setter. And here's where I'm going to try to edit what I did before. We're going to set that to 0f to begin with. Great. So those are our three properties. And if we go back and we look at stove, we had this method that we called and it could cook that doesn't exist there yet. So let's add that cook method right down here. So beneath cook progress, we're going to make a public void cook with a capital C, float amt is our argument. And we say if cook progress is less than 1f, cook progress plus equals the amount that I send in there. So this is just sort of, we're capping it a little bit. We're being a little bit loose about it, but that's fine. And every time we call the cook, we cook it by the amount that is being told to cook by right there. So that will increase our cook progress. Now, this will increase our cook progress, but the user won't see any way that this actually progresses. So I'm going to go back and we're going to set up a little bit of stuff here, and then we're going to code the second part that will actually make a visual indicator for this begin. We already have the beginnings of that there, but we'll do the second half here. So let's return. There must be an implication here. Cannot convert from double to float. We'll turn that into a float with an F there. This is inside of stove.cs, by the way. I put 0.001. Not certain why. Oh, there was an F there. I just didn't catch. When you're doing things in here, we almost never work with doubles in Unity. So you're almost always putting Fs at the end of your decimals, your things with decimal points in them, to indicate that they're floats, which are smaller, more manageable numbers. Great. All right. So now that's all compiling, and we're going to go find our one piece of food that we had created, which was the pizza. And it's inside our prefabs. And I'm going to double click on pizza on our prefabs to open up the prefab itself. Maybe that's why it's hovering. It's actually really far up there for some reason. So I'm going to zero out its position. That one is zeroed out. That's good. And so we're going to, with that root object selected in our pizza, we're going to click add component. We're going to add the food component to it. We're going to give it the name, the food name of pizza, even though it has it. We're just going to be very emphatic about the fact that it's a pizza. And then you can see that there's this last one here that says cook bar game objects. We're going to make a bar here that just represents how cooked it is. So I'm going to here, and this is going to be like not great, but it's going to get the job done. We're going to go to game object, 3D object, cube. And we're going to pull this cube a little bit above, and then we're just going to scale that sucker down. I just realized this is not the way I set it up. There's one trick here that we're going to have to play, and I want to double check and make sure that's actually the trick I played. Correct, yes. So forgive me, we did that a little bit too fast. We're going to go to game object, create empty, and we're going to call this one bar with a capital P or capital B. And we're going to position this bar so that it's above whatever food we are cooking. So why is this recompiling every time? What the hell is happening? What? Whatever. So we're going to get that so it's above the food. That looks okay. And then inside the bar, we're going to right click on bar, go to 3D object cube. So the bar itself has a scale of 1, 1, 1, but the cube is what we're going to scale down. So it looks like sort of a three-dimensional bar on top of this. We could also do this via the Unity UI system, which would be fine, but I would prefer not to delve into another system, so I'm going to work it this way. And just to be sort of finicky about it, I want a different material for this, so it's not just a white bar on top. So I'm going to go back to our root assets folder. I'm going to right click. I'm going to go to create folder, and this one will be our materials folder. So materials with a capital M. Open up that folder, right click inside that folder, create material. I'm going to name this material bar material. It's fine. We can do anything with this material, but in my case, I'm going to change its albedo to sort of a green. I find that this works for my visual language, and I'm going to drag that material onto the bar. We could have a little bit of fun with this too. I like, for quick and easy, just dumb things, I like to go click add emission on that material and give it like a weird sort of emissive too, because the combination of albedo plus emissive can come out pretty interesting sometimes. Yeah, that'll work for me. Whatever. Cool. Now, that did not come out quite the way I wanted it to, but whatever. Okay, so there's our bar material. It looks like a bar. It's hovering above it. Wonderful. I'm actually going to go ahead and scrunch. Do I need to scrunch that bar down? No. I'm going to select the root bar object, the upper bar, so the one that is containing the cube. And I'm going to set its scale X to whichever one is its long scale, which in this case is Z. It scales Z to 0. So now it's just this one little thing that's hovering above it. Great. Take note of which scale that you had to set there. In fact, we could come in. No, I'm just going to do that. So take note of which of those that you had to set. I had to set Z. That's going to be important for this next bit of code that we write. Now that we've added that bar, we can go back and select the root game object. And where it says cooking bar none in our food script, we can drag the bar object on top of it to specify that to be the bar. Awesome. So that's good. We can close. We can return to our code now. So we have here food object and food set point. But as they change the amount of doneness, I want my bar to also update and show how done this is. And we're going to do that by setting up some of these network callbacks for when we change a networked object. So I'm going to come back to the networked for my, not stove, good grief, for food. I'm going to come back to the network for the cook progress here. And I'm going to add the onChanged events for this. So I'm going to put parentheses right after the word networked before the cook progress. And inside those parentheses, I'm going to write onChanged equals name of, and then I'm going to open parentheses again. So you're going to see we're going to have two closing parentheses at the end here. Name of update done amount. So what this says is when you change this variable, such as when we're changing cook progress here, go ahead and also invoke this function. We've never done this before. This is part of our sync var stuff. And we're going to make that function down here. So public space static space void space update done amount changed food space changed with a lowercase c. All right. So when you have a networked variable like this, when you want to update, have a function that gets called when it runs, you don't make it a normal member variable of this class. Instead, you make it a static member, which means it belongs to the class template rather than the class itself. There's some fun rules and logic around that, but that's sort of the highest level of way of thinking about it. You can't invoke this function by saying, it's not possible to say this dot update done amount. It's not possible, but you can write food dot update done amount. So it kind of exists for the class itself, the class concept itself. When this one gets called, we have this thing called changed, which is in reference to the particular game object script that has it. And this is the script that is being changed. So it's calling the change method. And down here, we're actually not going to do much with this. So what we're going to say is when that gets updated, changed.behavior, which is this class that we're writing essentially. So we're getting back to this class by writing change.behavior, which allow us to call things on here like cook, for instance. But we're going to make a new method that updates our UI for us. So update progress UI. So this method doesn't exist yet. We're about to code it. So it says, when you change this here on the server, go ahead and run this function on every single player's connection. So now we're going to write the update progress UI. We're going to make it public void update progress UI. And this is actually relatively simple. So cook bar dot transform dot local scale is equal to new vector 3. And then we're going to put the cook progress variable here. in that area that it controls the size of our thing. So if we come back and, oh my God, Unity. So if we come back here and we look at mine, the one that controls the size of my bar, if I select the bar here, is none of them. Cool. Why is that one not affecting it anymore? The other two do. It's not even... So it's Z. I don't know why my Z manipulator here isn't doing anything. But it's Z, right? So Z is the thing that makes my bar look smaller or wider. So that's the third argument to this. If yours is different, it's going to be that one. So if yours is X, it'll be the first argument. If it's Y, it'll be the second argument. I wouldn't recommend Y. And if it's Z, it'll be the third. So for me, it'll be 0F, 0F, cook progress. Great. So now we have, for stove, if I'm holding something, I'm sending that food object a message saying, hey, cook yourself, right? When food gets that, it goes ahead and updates the cook amount. When this cook amount gets called, it goes and says, for every single connected client, I need to update the progress UI, which makes that bar become a bit larger. So I think we have all the connections made here. Likely we're going to have to debug one or two things, but that's the nature of writing code. So let's come back to Unity and let that compile. I'm interested, is this still, I don't know why this is bugging out. So we're going to go back to our main scene. We're going to click the play button. We're going to go ahead and host real fast. We'll walk our character over. We'll pick up a pizza. We'll walk our character over here. We'll donate that pizza. And I do not see progress, which is, like I said, we probably needed to debug something. And I'm not certain what that thing is yet. Okay, returning to this. This is, of course, why I try not to record too late. But it always happens anyway. You just record when you have time to record. I put zeros here, so of course it's not going to be visible. I scaled it down to infinitely small. So those zeros in food.cs for cookbar.transform.localscale should be 1F and 1F rather than 0F and 0F. While I'm at it, actually, I'm just going to go quickly and change this to 1F for Z and change the X to my cook progress. So that's going to require some quick editing in the editor, but it's going to be for the best in the end. So now that we changed that, I'm going to go ahead into pizza. I'm going to go to cube. I'm going to set this to 1. I'm going to set my cube's X to be the long part, which is going to look a whole heck of a lot better once we get it there. The Z still being finicky for some reason. So you want it so the X is the longest of them all. And then I'm going to set the X to 0 for this one. Awesome. So with that set up, if we run this now, and we click Start Host, we can come over here, we can click, we can create, we can click again when we're over there, and we'll see this bar will slowly fill as the pizza cooks. It kind of floats up there, which is troubling, but that's fine. Let's set it up next so that we can actually move that pizza over to deliver to a potential customer. So we're going to return to our stove script here. Scripts, stove. I'm going to open that up. And we're going to go back to interact. So right now it says if we don't have food, go ahead and deposit the food, which sort of stands to reason then that if we put an else in there, that means that we do have food. So there's only kind of two states, either you do or you don't, sort of thing. So we're going to do the same thing that we did before. We're going to say initiator dot get component cooking character controller dot, instead of this one delivering it, we're going to tell it to pick up the object. So dot pick up object, my food object, which is a network object. So we actually have to sort of deliver it a little bit closer to the game object itself. And then we're going to say, hey, this particular script, the stove no longer has food, so false. Don't have food, I can accept new food, and food object equals null. So there's nothing being carried by this. Now, pickup object doesn't exist in our cooking character controller yet, I don't believe. Actually, no, it does. Yeah, so we're just going to use that exact same code, but going the other way so we can pick it up again. And so the moment we pick up this food, it's not going to be stored on the stove anymore. So the stove will stop sort of applying its method to it, and that delivery method will stop. So we'll pick up an object, we'll deposit the object, we'll let it cook for a little while. I might go off and do something else. Don't really know what we'll do. We'll come back, we'll pick it up again, and then we could conceivably deliver it to a customer that we don't have yet. So let's work on that customer as the next piece of the puzzle here. Let's get a customer coming in and sort of wandering around and figuring its life out. To do this section, we're going to need a place for a customer to spawn. So we're going to go ahead and go to game object, create empty. And then we're going to position this where the customer is going to spawn. For me, I'm going to position it in this game in the far upper right. We could get pretty crazy with this, but I'm going to go simple with our customer spawner and do a variation that we've probably seen before also. So there's my customer spawn location right over there. And I'm going to rename this to customer spawner as well. And then let's go into our scripts. So we're going to go into our scripts folder and we're going to make a new folder called customer spawner. Very exciting. Awesome. And once we've made that customer controller, we're going to go ahead and open it up, or customer spawner, and surprise, it's going to be using Fusion. So using Fusion, which is a network behavior. And then down here, we're going to have a thing that will allow us to make a customer. So these two can go, we don't need them. We do need, however, the customer we want to make, so public game object, customer prefab, which we'll be working on in a second. And then beneath there, public void make customer. Awesome. And then we're going to say var customer is equal to runner.spawn customer prefab. This dot transform dot position. So it's going to go ahead and make that customer and put it exactly where this customer spawner is. Awesome. So we're going to stick with that for now because actually we need to focus on the customer itself first before we do much more. So we'll come back here and let that compile. We'll select that customer spawner and we'll attach the customer spawner script to it as well. So get that script on there. It needs a network object, so get that on there well as and save. The next thing we're going to do is make the customer for this. So we're going to go to game object, create empty, and name that empty customer. Doesn't really matter too much about where it's at because we just sort of need a prefab, but I'm going to drop it down here real fast just because. And for my customer, I'm going to give it a prototyping thing. So it's going to look like the pill person that I have over there for now. So with customer selected, I'm going to right click on it. I'm going to go to 3D object and I'm going to make a capsule. So there's my capsule for my customer. I prefer when possible to have these up but I think this will be fine for now. Okay, so there's my customer. And then to make the customer move around, we are going to give it a, oh my gosh, what are those things called? A nav mesh agent, which is a thing that allows it to navigate around a space, sort of understand some space. So we're going to, with the customer root object selected, we're going to hit add component and say nav mesh agent. So this cylinder that you see here represents the agent. It matches up with the customer pretty well. I'm going to pull that that thing up a little bit more until it sort of matches up with the bottom of the cylinder pretty nicely. Awesome, cool. So that is going to represent our customer for better or for worse. And this is going to be a networked object. So let's just go ahead now and add a network transform to it. I wonder, no. So we're going to add a network transform to it. And we're also going to add a network object to it so it works. Since it needs an interpolation, I oftentimes don't really trust any of the other interpolations, so I just make an empty game object as a child of the root object that is that target, and I set that as the interpolation target there. So now I have my network transform all set up for my customer with that nav mesh agent on the top. Now this nav mesh agent won't be able to navigate around the space yet because it doesn't know anything about the space. We have to pre-compute a lot of stuff about the space. To do this, we're going to have to use a different window in Unity that we may not have explored yet. So I'm going to go to Window. Ooh, I've never seen the Fusion window before. I'm going to go to Window. I'm going to go down to AI, and I'm going to go to Navigation. And it's going to pop up a tab. Typically over here, you want to look for the Navigation tab. What we need to do is we need to set certain parts of this world as walkable. And the part that's important to me to be walkable right now is this ground here. So select the ground and then go to Object on Navigation and click it as Nav Mesh Static. Yes, change children as well. And then make sure it's set as walkable because there's other ones too of not walkable and jump. So make sure it's set to walkable. So just the ground needs to be walkable. If you want to be really crazy, you can set these as static too and set them as, what do you call them? Not walkable, but I don't really care. Just set this as walkable. Once you've done that, in the navigation pane, go to the other tab up here that says Bake, so Navigation Bake. And we're just going to go with all the defaults now. We don't really need to play around with anything, so I'm going to hit Bake. And it's going to create this light blue area here. So if you see this light blue area that's visualized on top, that is the walkable space for our character. So for instance, we could select these two, go to Object, go to Nav Mesh Static, set them as not walkable. And then now that these two have been set as not walkable and the ground is walkable, when I hit Bake, it's going to select an area around there that says, oh, this character cannot move beyond this space. He can't walk there, or she can't walk there. Not acceptable. So we'll go with that. I think that will be fine for this particular game. So make sure that you've had this this piece baked here because it's going to be important for the next piece of this code. Now that we've done that, I'm going to right click down here in project. I'm going to go to create. I'm going to make a customer or a new C# script. And I'm going to name it customer. And all sorts of awful things will happen. It opens up Visual Studio even though it doesn't need to. And once it does that, then I can actually open the customer script. And boy, you'll be surprised using Fusion. So using Fusion, this is going to extend a network behavior. I do this sometimes even when I don't need to, just because I kind of assume that I need to. So let's start easy and build our way up from there. I'm going to go ahead and delete these two because I believe I do not need either of them. Oh, I use update. Somehow that works. I won't ask why it works. And we're going to start with some simple stuff first. So private nav mesh agent. Oh, and to be able to use navmesh agent, we actually need another import as well. So after using Fusion, we're going to be using Unity Engine.ai. So we're going to use that as well, navmesh agent. These other things we'll get to soon. Awesome. And so then immediately after that, I'm going to do a new function, void awake with a capital A. And this is a variation of the start. So if you've done any programming Unity before, awake is similar to start in many ways. Just plays a little bit nicer with us when we're writing Unity code. And we're going to set that agent. So agent is equal to this.getComponent navmesh agent. So we're setting that agent there. And then beneath there, I'm going to go ahead and set up a quick method to tell it to go to a table. So public void, God, I wish I could spell public void go to table, vector3 position. We'll call this table position just in case position is some sort of special keyword. So table position, and we're going to say agent dot set destination table position. So what this is going to do when we encounter this line of code is it's going to tell it to point somewhere on this map, presumably this walkable area, for it to go to, and the agent is going to walk over there. It kind of rules. The moment you tell it to do that, so long as it can find a walkable path, it will walk there. Now our customer needs that capability, needs the script attached to it. So we're going to go to our customer here. We're going to attach that customer script to it. Beautiful. And in this case, I'm actually not telling it here where to walk to. So I'm going to tell it when I spawn it. So customer is going to have some more stuff done with in the future, but for now, we're going to go to the prefabs folder. We're going to grab customer. We're going to drop it inside of the prefabs folder. And then we're going to delete the customer that's here. Now, in this case, I have these two tables here, and I think these are the places I want the customer to come to. Maybe they'll look a little bit more like that. And the way that I've programmed this is that I just sort of get one of them. So I'm going to tag them, and I don't have a tag for them yet. So I'm going to go select any game object, actually, it doesn't matter. And then go to where it says in the inspector tag. I'm going to go to add tag. I'm going to click the plus button at the very bottom, and I'm going to name this tag table with a capital T. And then I'm going to come back to each of these and tag them as table. So now these two objects that I have here are tagged as table. And with those two objects tagged as table, I'm going to go back to customer spawner. And when I spawn the customer, in addition to making the customer, I'm going to find a table and tell customer to go to the table. So to find the table, I'm going to do a quick sort of heavy search using game object table. Is equal to game object.find. Game object.find game object with tag. I'm going to do singular here, which is probably always going to return the same table. We can do multiple and some extra code on top of that, but I'll leave that up to your coding chops. And we named that tag table with a capital T, so we're going to put that in as table with a capital T there. And then beneath here, we're then finally going to tell the customer to go to that table. So customer dot game object dot send message go to table, comma, table.transform.position. So go to the position of that table, and then send message options that don't require receiver. Awesome. Save that. return to Unity, let that all compile. We're going to have to attach a couple of scripts and we're going to test it. So there's customer spawner. Customer spawner doesn't have that prefab yet. So let's go open up our prefabs and there's our customer. So I'm going to drag and drop that customer prefab on there and I'm going to go ahead and now give this a run. And we'll click start host. Oh, we don't actually spawn a customer yet. So can we just do that right away to test it? It runs into an issue, which I think is going to affect us if we try to do it. But it'll be educational for us to see that so that we might understand why that's an issue. So I'm going to go to customer controller. And I'm going to actually put it on awake. And then I'm going to say make customer. So right as the game starts, we're going to try to make a customer via our customer spawner that's sitting over there. And if I recall, this doesn't work, and so that's gonna bring us the next step, the next phase to begin the game proper. Yeah, so we're not seeing a customer, and I believe we get this. It says object reference not set to an instance of an object on line 18. Well, that's actually more troubling than I would have guessed. It's not what I expected to be going wrong. The only things that couldn't be would be this dot transform that doesn't make sense. Or runner. Ah, yes. So runner doesn't exist yet. So that was exactly the issue that we run into, is that when we hit await, we're actually not connected to the thing yet. We have to wait until we're connected for some of these things to begin. So let's return to cooking. Oh my goodness. Come on. We didn't even do anything. So let's return to Unity and we're going to go and cheat a little bit. And we're going to put a pad over here that will begin having the customer show up. So I'm going to go to game object. Did I do an empty or did I just do a cube for this one? I'm actually kind of curious. Are you empty or are you a cube? Oh, you are empty. It really doesn't matter that much though. We're just going to do a cube. So we're going to go to game object. We're going to go to 3D object. We're going to go to cube. And we're going to scale. Oh, I know why this actually. And we're going to call this start zone. So when the cube's added, rename it to start zone. And then I'm going to scale Mr. Cube down a little bit. It's a little bit flatter. And I'm going to put it somewhere on the floor, maybe over there. In fact, I might even make it a little bit bigger, easier to access. And then I'm going to edit the collider, so the collider might be a little bit larger as well, a little bit easier to run into. And I'm going to set that collider as a trigger. Wonderful. Great. Now that we've done that, we're going to return to our script. So we're going to write a script for this start button here. I think actually I like to put another material on it too, so I'm just going to drop that bar material on there. And so we're going to return to our scripts folder. And in our scripts folder, we are going to make a script called start zone. So create C# script start zone with a capital Z. I don't know where the script is existing in my cheater one, so awesome. Great, so then let's go find that start zone. We'll open up that script. We don't need either of these. In fact, in this case, we don't even need it to be a network behavior. So public space void on trigger enter. So once something with a trigger enter one's collider other, if other dot game object dot compare tag player game object dot find customer controller. did we call it that? We call it customer spawner. Customer spawner dot send message make customer. Awesome. So now we're sending that, and then we're also just going to go ahead and turn this off. So this game object dot set active false. So we're going to turn off this object. So essentially it's just this button that we walk onto, sends a message to another object, and then deactivates itself, so it's not part of the game anymore. Is this a bit of a cheat? Yeah, it is, but whatever. So I'm going to attach that start zone script to the start zone object. There it is. And now we're going to cross our fingers and hope this variation actually works. Start host. Wonderful. I'm too high up to collide with it, I think, which is intensely troubling. Or my character isn't tagged as a character. Let's make sure real fast. Cooking player. Cooking player is not tagged as a character, which if we go look at the script is a requirement to get into the rest of the code. So we're going to go find the cooking player in our prefabs. We're going to go to its tag, and player is a default tag that Unity gives to us. Let's try that again. Debug that step first and see if that is the issue. Let's hope. No. No. Let's do a few more things here then real fast. Let's make our collider egregious. How about it's just really tall? Because I see my character floating and I'm wondering if it's the float that's getting us. This is, of course, I think I mentioned in the last video, I said like, I don't recall all the ways I did this. Yeah, so I just need really tall. Now you see he walks over there and he stops. Now we're going to do some things to make this customer a little bit smarter. I don't think in this particular video we're going to tackle that particular issue. Well, we might get started on it. But that's going to be sort of the next step, is how do we make that customer a little bit smarter. Let's begin on that step actually, and then we'll start that and we'll finish that in the next video. So let's work on making that customer just a little bit more intelligent than they currently are. So we're going to open up our customer script here. Oh, there's so much to this particular one. Okay. So next we're going to work on a bit of the intelligence. What we're going to do is we're going to set this character so that we can tell in what state they're at. And we're going to make something called an enum, which is short for enumerator, which allows us to specify sort of different little tags. So walking and waiting are going to be 2 here. So we have 2 tags here. We might use strings or other things here. This is just nice because we know that they can't vary in any way now. And then using those, I think using those is all we need. We're going to hop down into the update method that I stated here, and I'm going to say if state double equals state.walking. We're going to do one thing. And then since our enum right now is only 2, we can do this, but I might even be like else if state double equals state.waiting. Wonderful. And it's not state with a capital S, good grief. So beneath here, we're going to do a private state with a capital S, state with a lowercase s, and we're actually going to set that equal to state.walking to begin with, which changes these to be state with a lowercase s for each of those. Now we have this toggle that says either run this code if we're walking or this code if we're waiting. Yes, there are things called state machines which are much better for this, but I'm not going to worry too much about it. So we'll get to the waiting part here later. This is sort of for getting angry and leaving is sort of what we're going to do here. But here this is where we're going to focus on like stopping and switching to waiting. Oh my God, waiting state. So there is a problem here. So we actually can't do any of this. We can't do any of this if we don't have a path yet, because we're not even walking yet. And if we're not walking, we can't run some of this other logic. So if agent.path pending, which is essentially just saying if the agent doesn't know how to move yet, just leave. So the agent doesn't know how to move yet. Like, it doesn't know its path. It's not moving at all. We're just not going to do anything. And then we're going to calculate what I assume is close enough in air quotes. If agent dot remaining distance is less than 0.05, so it's remaining distance to its target. This is where we're going to do the order. So, which we will get to. This is a to-do. And then we're also going to wait. Come on. Come on. Good grief. State is equal to state dot waiting. And this essentially toggles us out of this walking state into the state. So once we get close enough, they're going to say their order and they're going to start waiting for their order. And then their patience will begin to drain. I think we're going to get to the patience mechanic in the next video, however. Great. And let's give that one more run just to see how that looks and feels on our character, because I think we're going to get a stop a little bit earlier than we had before. So let's spawn that character. They're going to move over. No, maybe not. Okay. So we've got those states there. Let's finish off the waiting, and then we'll be done for today. So cooking network. Let's hop down into hop up to our stuff up here again, because we need something that controls how patient we are. So we've got our states. Now we need the stuff for our wait. So we're going to have a public float wait cooldown equals 5F. We're going to have a public float patience equals 0.02F. And I think that's all we need for now, because the next ones are all food-based. Great. Oh, we need one more thing, which is a public, private vector3 home, and this is where we return to. Awesome. So we're going to set home on awake, and this actually doesn't work the way I want it to, but whatever. Home is equal to this.transform.position. I'm not going to worry too much about that for now, because we can fix that perhaps in a later video. And then down in our waiting, when we're waiting, we're going to say wait cooldown minus equals patience. And then if wait cooldown is less than 0, we're going to say agent dot set destination home. So they're going to go back to where they started. And then we're going to set the state equal to state.walking again. And this is going to set them walking again, because they're going to exit out of this waiting state the next update. So we're going to save that. We'll return to Unity. We'll let it recompile. We will click run. We will start host. And no matter where we're at this point, this is going to be where our game pauses for now. I forget. Yeah, so we see they come there, they leave real fast. So we need to play with those numbers a little bit, but we have a AI in heavy air quotes here that wiggle woggles all over to their order table. We're going to get their order and their desire in the next video, and then if they're not fed soon enough, they leave. They wander off. So that's going to be it for the second video. The next video is going to focus on delivery and feeding the desired things here. And then we're going to move out of the game itself and into the cruft that surrounds this game. So, so character customization and menu screen to sort of pull this into at least a full and semi-complete demo situation.